We are usually given the rule for solving a division of fractions problem such as 2/3 divided by 3/4 by following the rule of flipping the second fraction, thereby 3/4 becoming 4/3, and multiplying. So the question arises, why are these equivalent? The division 2/3 divided by 3/4, why is it equivalent to 2/3 times 4/3? Another way of thinking of the division of fractions is a comparison of two areas. That is, in this case, this would read, what is 2/3 compared to 3/4? Or if we look at the areas over here, what this 3/4 area, what is this 2/3 area compared to this 3/4 area? Each of these individual fractions, 2/3, is compared to this entire rectangular area divided, in this case, in thirds. And so we compare these thirds to the whole, and we say that this area is 2/3 of this rectangular area. And the 3/4, the same rectangular area, has now been divided into fourths. And we say that this area is 3/4 compared to the entire rectangular area. Now in the division problem, 2/3 compared to 3/4 asks the question, what if we don't compare the 2/3 to the entire rectangular area, but only compare the 2/3 to the 3/4 area? Then what will be the 2/3 as a fraction of the 3/4? A practical example of this would be if the 3/4 represented a measuring cup. We have a 3/4 measuring cup, and with that 3/4 measuring cup, we want to get 2/3, fill it with 2/3 of a certain ingredient. How much of this 3/4 measuring cup would we have to fill so that it would equal 2/3 of a certain ingredient? Now, if we look at this 3/4 area, we can see as whole, it has 9 parts. So there are 9 parts to this 3/4 as the whole. And if we look at the 2/3, we can see that it has 8 equal parts of the same size. So we can say that the comparison of the 2/3 to the 3/4 is 8/9, 8 of a ninth, just by looking at the comparison. So we would have to fill the 3/4 measuring cup 8/9 of the field with the ingredient to get 2/3 of that ingredient as compared to this entire rectangle. So we can see that 2/3 divided by 3/4, or 2/3 compared to 3/4, does equal 8/9, or 8 compared to 9. So what does it mean to flip the second fraction and multiply? As previously stated, we said the 3/4 is now considered the whole that we referenced instead of the entire rectangle. And so when we flip 3/4, that's what we are doing. Since this is the whole, and now each fourth is a third of that whole, when we flip the 3/4, we get 4/3, which now references this entire rectangle. We now have the entire rectangle. Rather than being fourths, we now have each part is a third, and there are 4 of those thirds, one more than composes the whole. So now, if we ask what is 2/3 of that 4/3, we will see that since there are 12 equal parts of the rectangle now, that 2/3 of those will equal 8, exactly what we have for the initial 2/3, these 8 equal parts. 2/3 of 4/3 will give us 8, but in reference to the whole, which is 9, we now have 8/9. So by flipping the second fraction and changing it to multiplication, we have the equivalent to the division problem, 2/3 divided by 3/4. In the first case, we say the 2/3 of the entire rectangle, being 8 of these parts, is compared to the 3/4, where we see there are 9 parts. So we get the 8 compared to 9. And then the 2/3 of the 4/3, the 4/3 now being just a redefinition of the entire rectangle in terms of what now is the referenced whole, the 3/4, will give us 4/3. And again, 2/3 of that 4/3 also equals 8/9. So we can see logically and mathematically these two statements are equivalent.